Hello everyone, this is my remote sensing project. I built a LiDAR device that will be scanning my desired target. This LiDAR device is made out of a Raspberry Pi and a camera, as well as a laser. The Raspberry Pi is using Python coding to make measurements between the camera and the target that I selected. The target I selected is in front of the subway near Lot 1 on the UMD campus. I select this target because it's very unique and has a lot of curves and edges. So this is my LiDAR device. It took me about a week to build. It uses an old laptop screen, and I had to use some special controller board ordered off of eBay to make the screen work with the Raspberry Pi, which is right here. I have a Raspberry Pi camera, which is directly connected to the Raspberry. I have Arduino inside. This is the cord, and that also has a accelerometer to measure the angle changes with the tripod. The angle changes are very important when scanning the object. Also have a bunch of buttons here. This one turns on the Raspberry Pi screen, fan, and voltage reader, which you see right here. I want to keep track of the voltage so this thing doesn't die on me. Right now it's running off of one lithium battery. I just want to show you all the wires, how it works. It can be run by 2 lithium batteries or an external cord, which can make the device run as long as I want. And this is my tripod. It's about 20 bucks, pretty cheap, very sturdy. And I have the laser going on right now, and it's actually tracking it with that red laser dot and giving out values, which tells you how far away the laser is. I built this device because it's very unique and it was fun to build. I used wood for the outer shell. I sanded it, painted it, cut it in probably like one day or so. And I also have a USB plug-in right here for my keyboard and mouse, so I can have all that wireless. It's pretty easy to use outside. I didn't want to use the VCN. I just had a lot of issues in the past with that, so I wanted to do something I can see right in front of me instead of using my laptop and connecting to the internet. That's pretty much why I wanted to do this type of build. For the original testing calibration, I had the LiDAR device make measurements between 0 and 10 feet with 6-inch increments. The red line on the left side of the screen is my actual data, and the blue line is the theoretical data. To improve the variance that you see on the left side of the screen, I had to update the RO and RPC values in the MATLAB coding. The MATLAB coding is what I had my data run through to make this graph. On the right side of the screen, you can see that the red line is almost identical to the blue line, which is exactly what we want. For my range data collection, I scanned my target on 4 different sides, starting from the top and went down, up, down, up, down, up, down. I did this so I had a better 3D point cloud of the target and a better outcome for the 3D print. So there was a few complications during the scanning process. One being the lights, they were really bright and messed with my camera trying to track the laser dot. Also, it was windy during the time as well, which almost blew away the tent that was trying to block the light. Therefore, I rushed my scanning and I didn't get enough points that I wanted. I probably could have went out there again, but due to time constraint with other finals and projects, I just had to go with what I had. I did state that I rushed the data collection, but in this picture you can see that the MATLAB graph shows the data is quite similar to what I measured by hand, 4 foot and 8 inches. At this point, the data that I collected is now being processed through MATLAB. One of the outcomes were 3D point cloud graphs with the back, front, left, and right views. Unfortunately, the data turned out upside down because the cell are being backwards. That's what I believe. To correct that, I had to change some values in the MATLAB coding. At this point, the range data from the MATLAB was transformed to Mesh Lab data points. I had to rotate and translate these data points to create the 3D structure. I'd say this is very difficult to do, and unfortunately, it actually changed some of the features that I wanted to see on the 3D object.